calculus video on 3.5 derivatives of trig functions. So before we get started again with the problems, we're on number 6. Just wanted to remind you about a few things. The derivative of sine is cosine, which is positive. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. The derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. So, like I mentioned in the other video, the derivatives of the C ones are negative, whether it's cosine, cotangent, or cosecant. The other thing you're going to need to know for these upcoming problems is these are called the Pythagorean identities. And so the first basic one is sine squared x plus cosine squared x equal 1, which means if you solve for sine squared x, then it'd be 1 minus cosine squared x. And if you solve for cosine squared x, then it's 1 minus sine squared x. So you can solve for either one. You also have 1 plus tangent squared x equals secant squared x, which means that tangent squared x is secant squared x minus 1. And you also have 1 plus cotangent squared x equal to cosecant squared x. So that means if you keep cotangent squared where it is, it's cosecant squared x minus 1. So first off, where you find those, you might have a packet which looks like a unit circle. And then here's your reciprocal identities, your quotient identities, your Pythagorean identities are what we're talking about right there. And then there's some other stuff. But these are the ones you're going to need. Okay, so getting back to the problems, we did the first 5, and now on this one, number 6, we're finding the derivative of 3 cosine cotangent. So what we want to do is treat this part as the u function and treat this part as the v function. So for y prime, we're going to use the product rule, and so we're going to say v u prime plus u v prime. So the v is cotangent. The derivative of u is like this. Okay, so if you have the derivative of cosine, it'd be negative sine. And so this is negative 3 sine x. Now we need a plus sign, and we keep the u part the same, which is 3 cosine. And we multiply by the derivative of v. Well, the derivative of cotangent is negative cosecant squared. So negative cosecant squared. Now, before we do any simplifying, let's rewrite these where the negative 3 is in front. Now, what is cotangent? If you go to your reciprocal identity, cotangent is listed as 1 over tangent. And what I'm trying to get at is, oh, here's the other one. The other definition, which is called a quotient identity, because it involves division, whereas this, yeah, it involves division, but it's reciprocals, because those are ones. The cotangent can be rewritten as cosine over sine. So you have cotangent, which is really cosine x over sine x. And then we're going to still have our sine x. And then we have minus 3 cosine x and then cosecant is 1 over sine. Squared x. So when we simplify this, our divide by sign and our sine cancel. And so this is negative 3 cosine x. Now this part, we can simplify that also. But it looks like in this case, we don't have to do any simplification. It looks like we could have just left this as negative 3 cosine x and then keep this as cosecant squared x. And these are equivalent because, you know, they just put this one first. And then put this one in the back. So they just switched places, and so that's your answer. Okay, on our next one, we have cosecant divide by secant squared. What I'm first going to do is I'm going to write that as cosecant x times 1 over secant squared, because those are equivalent. And before I even do any derivative, I want to see if I can simplify or cancel out anything. Well, 1 over cosecant squared is the same as cosine squared. So we can call this, I was going to put y again. We put cosecant x times cosine x squared. So in other words, 1 over secant squared is equivalent to cosine squared. Now, again, let's just continue. Cosecant is 1 over sine. And again, we have cosine squared x. Well, what I see is this is going to be a lot simpler if we just keep on making this as cosine x over sine x times your cosine x, because that is equivalent to cosine squared, and then this is going to just be cotangent x times cosine x. So that is a much simpler expression. Now, that's still just what y is. I haven't done any derivative. So now, for the derivative, you take this is u, this is v. So we said v times u prime plus u times v prime. So we're going to have cosine x times the derivative of cotangent. So that's negative cosecant squared. Remember that if you go to cotangent, that's negative cosecant squared x. And so that took care of the left side. And then we take u, which is cotan x, and multiply it by the derivative of v, and the derivative of cosine is negative sine. So then we just put the negative in front, and you have your cosine x times cosecant squared x, and then minus sine x. We usually put sine and cosine in front of cotan or tan. And so that is actually the exact same as what we have right there. So my thought on that one, again, was simplify it as much as you can before taking the derivative. Simplify before taking the derivative. Now what I noticed is some of these may not have view an example, and so you're going to need to use my example or find another way which is not against the school rules. So now on number 8, we have tan, and we have 1 plus tan x in our denominator. Well, this one is going to make you use the quotient rule. So the quotient rule is v times u prime minus u times v prime over v squared. So the v is the 1 plus tan, and then the derivative of u means the derivative of tan. The derivative of tangent is secant squared. And then we put minus u, which is tan x, times the derivative of v. So the derivative of 1 is just 0, and the derivative of tan is secant squared. And then this is over your denominator squared. So when I'm thinking through this, I have a term with a plus sign, and I have something here. That means I should distribute it. So 1 times secant squared is secant squared, and then tan x times secant squared x, and then minus tan x secant squared x. So the plus and minus of the same thing cancel, and that's over 1 plus tan x squared. And so that is our answer. So now on this one, we have 6 over cosine. So you might just want to write that as 6 secant x. And then it's 5 over tangent x, so you might just want to write that as 5 cotangent x. So that's just rewriting what y is. Now for y prime, you just take this term, take the derivative, and the derivative of secant is secant tangent, because that was over here. The derivative of secant is secant tangent, and then the derivative of cotangent is negative cosecant squared. And so you can rewrite that to be 6 secant x tan x minus 5 cosecant squared x. And that's our answer. Okay. For this one, think about how the function logically groups together. For example, I would group this to be u and this to be v. At least that's my first thought. Yeah, I would group it that way because this is like a regular polynomial part and this is the trig part. So we're going to use the product rule. So the v term is sine x cosine x. And then the derivative of u is 30x to the fifth. And so I'm going to go ahead and put that in front. This is y prime, not y. So y prime is 30x to the fifth sine x cosine x, which already matches the front. You know, we're already done with the first part. Now, we also have u times v prime. So what that means is we have 5x to the sixth times the derivative. I'm going to do with this notation of sine x cosine x. The reason why I'm going to do that notation is because that's going to be its own separate product rule. This needs the product rule also. So the front part is done, and then for this, I'm going to call this part u and this part v. And I'm just going to put my 5x to the sixth in front of everything. Okay, so this would be v, like we follow the formula, v times u prime, cosine times the derivative of u. The derivative of sine is cosine, plus u times the derivative of v. So the derivative of cosine is negative sine. So when I distribute this, this is like, I'm going to keep this front part the same. Distribute the 5x to the sixth, and this is cosine squared x. And this part is negative sine squared, so I need minus 5x to the sixth sine squared x. And so then if we just flip the order a little bit, we'd have exactly what it is. So we have 30x to the fifth sine x cosine x, and then they just moved this part to be here, minus 5x to the sixth sine squared x, and then move this part to be there, which is plus 5x to the sixth cosine squared x. And so that's our answer. Now, if they marked yours wrong for some reason, and it was in a different order, it's probably because you missed an exponent or something. Because Just being in a different order would not matter. But if you put x to the 5th instead of x to the 6th, that would matter. Okay, so now we're done with number 10. On number 11, we have tan t minus t. So the derivative of tangent is secant squared. And the derivative of t is 1. Now this is where you want to probably remember your Pythagorean identity. So we have 1 plus tangent squared is secant squared. 1 plus tan squared x equals secant squared x. Now what that means is if we move the 1 over, we have tan squared x equals secant squared x minus 1. And that matches that. And so then our answer from substitution is tan squared t. So you go from 2 terms to 1 because this is equivalent to tan squared x. So that's simpler than you think. Okay, on this one, we take the derivative of 5t squared. And so for that part, we get 10t, because we do 2 times 5, and then t, and then lower by power. And then we have this negative 2 secant t, and we have the 3. Well, the derivative of 3 is 0, so that doesn't count. But we have our negative 2, and then the derivative of secant is secant tangent. Remember I said the more you do these, the more familiar you are going to be with them. So if we go to here, secant is secant tangent. And we're already there. That's our answer. 10t minus 2 secant t tangent t. Oops. Make sure that's visible. But that matches in one step. That's a one-step problem. Bet you like that. Now in this one, we're taking the derivative of 3, which is nothing, and then we have to do our product rule. So I'm going to have r equal theta squared sine theta. So that is the same as if you were to say x squared sine x. But the thing is, on Math Excel, they would count it wrong if you put x instead of theta. So you could do it with either one as long as you change it back. I'm used to working with x, and so that's what I'm going to do. I'm going to call this part u, this part v, and we have to do our product rule. So that's v times u prime plus u times v prime. So v is sine x, and then the derivative of x squared is 2x, and u is x squared, and then the derivative of sine is cosine. So I get 2x sine x plus x squared cosine x. Now you're going to wonder, why didn't that match? Well, besides the regular theta thing, there's this little negative sign in front that we need to do. So we need to distribute negative 1. So this would be like from this part right here. So this would be negative 2 sine theta, negative 2 theta sine theta. I'm going to rewrite that. Negative 2 theta sine theta plus theta squared. I need a minus there because I just distributed. Minus theta squared cosine theta. And to match that, we need to be in the correct order, where we put the negative theta squared cosine theta and then minus 2 theta sine theta. So that just rearranged the order. Again, it would not count it wrong. I'm just trying to show you that it actually does match perfectly if you take that extra step. So you see, I left off this negative sign because that's a little more confusing. Now, if you want to do it the other way, if you want to do it right, you could say r equal negative theta squared sine theta. And you could say r prime is sine theta times negative 2 theta plus negative theta squared times cosine theta. And that's negative 2 theta sine theta minus theta squared cosine theta. And this part just goes to the front. And this part goes to the back. So you could take it all together in one process if you want to. Because if you forget that negative sign, you got to distribute this negative 1. So you may prefer it this way. It's up to you. And also you notice you didn't have to use x if you didn't want to. You could have used theta, and it worked out. Okay, so now number 14. This one we have the quotient rule. So for p prime, it's going to be v u prime minus u v prime over v squared. Our v is sine of p. Now we need our derivative of the numerator. So the derivative, that should be a q. Mind your p's and q's. You're telling me. Okay, so sine q times the derivative of sine is cosine. Oops, I don't need parentheses. And then the derivative of cosine is negative sine. So that's our v times our u prime. Now we need minus u times the derivative of v, which is the derivative of sine is cosine. All of that over v squared. Now let's start distributing and see what happens. So sine q times cosine q minus sine squared q minus sine q cosine q minus cosine squared q all over sine squared q. Now notice if we have sine q cosine q and negative sine q cosine q, those cancel. So even if you had rewritten it like cosine times sine, that would have canceled with sine times cosine, since it's only the same, it's the same variable q. Okay, so that cancels out. Now, in our numerator, we have negative sine squared q minus cosine squared q. What I would do at this step is remember your Pythagorean identity, which is sine squared x plus cosine squared x equal 1. So if we factor out a negative 1, we're going to get sine squared q plus cosine squared q over sine squared q. Now this part we're replacing with 1, so we just have negative 1 over sine squared q, and so then our answer is negative cosecant squared q. And that's your answer. Matches. Okay, now on this last one, we need to take our time because it says get the second derivative instead of the first derivative. So for y prime, the derivative of cosecant is what? It's negative cosecant cotangent. Negative cosecant cotangent. Negative. So I'm going to put the little negative sign in front of everything. Okay, so that's your first derivative. Now for your second derivative, we need to group this part as u and this part is v. We're using our product rule, so v u prime plus u v prime. So the v term is cotangent, and we have negative 5. Then what was the derivative of cosecant? It was cosecant cotangent. Negative. Negative cosecant cotangent. Whoops. Okay, so that's for our first part. And that part simplifies to a positive 5 cosecant x cotan squared x. We're not really distributing, we're just canceling the negatives, put the 5 in front, and then multiplying this term by that term, so it's cosecant, and then there's 2 cotangents. So that's cotangent squared. So that's for your first part. Then we have u. So the u part is negative 5 cosecant x. Now we need times the derivative of v. So our derivative of cotangent is negative cosecant squared. Negative cosecant squared. So then this turns into plus 5. And then this is cosecant cubed. Okay, so I want to factor out cosecant x. Actually, they didn't have it factored out. Let me think for a moment. Okay, so this is our answer in terms of cosecant and cotangent. And I bet in Math Excel it would accept that because I've seen it before. But the difference is that their answer on the worksheet is only in terms of cosecant. And when I looked at view an example, their example had 11 cosecant cubed, like our 5, plus 11 cosecant cotangent squared x. And so that is equivalent. Now let's follow their process to get to the last part. So now to only use cosecant squared, we have to do a substitution. And so this would be 11 cosecant cubed x plus 11 cosecant x. Then you have to do a substitution because remember that cotangent squared x, let's go to that Pythagorean identity. 1 plus cotangent squared x is cosecant squared. One plus cotangent squared x is cosecant squared x. And so if we solve for cotangent squared x, we get cosecant squared x minus 1. Now that's what they're wanting us to do right there. So we change this cotangent squared x to be cosecant squared x minus 1. Now from there, they want you to distribute. And so we have 11 cosecant cubed x plus 11 cosecant cubed x, because cosecant x times cosecant squared x is cosecant cubed x. And then you have to do negative 1 times this, so minus 11 cosecant x. Now there we're very close. We just say 11 of this plus 11 of this. They're like terms, so that's how they get 22. And then minus 11 cosecant x. And so that's the same thing we're going to end up doing. And so on ours, it would end up being 5 cosecant x cotangent squared x, which we need to change to cosecant squared x minus 1. And then plus 5 cosecant cubed x. So then this is 5 cosecant cubed x minus 5 cosecant x plus 5 cosecant cubed x. And then this and this are like terms, and so that's how you get 10 cosecant cubed x minus 5 cosecant x. And that does match what's on the paper. Okay. So again, in Math Excel, you could probably have it in terms of cosecant and cotangent. It's just if you're trying to match the paper exactly, and if you're trying to do the view and example exactly, they're going to have you do extra steps. Okay, hope that helps. Have a good one.